Hello, my name's Adrian Hopgood, and it's a pleasure to speak with you today. I'm going to discuss today two terms, agentic AI and multi-agent AI, both very current in the world of AI at the moment, although they have in fact been around for a while. But before I get on to that, I should briefly introduce myself. I'm Emeritus Professor at the University of Portsmouth, which means that I've retired from full-time employment there, but I am involved in a range of projects. I'm also an independent consultant working in practical AI. I've actually been involved in AI for around 40 years, having started in the 1980s when my first professional job after my PhD was working for a software company called Systems Designers, building practical AI systems, and I've worked in that field since. So, as I say, my talk today is going to be about agentic AI and multi-agent AI. Agentic AI means AI that can interact with its environment. That is to say, it has agency. Multi-agent AI is a different concept. Here, it's very much to do with the way the AI system is constructed. And I'm going to illustrate this with an example that I worked upon some years ago, which illustrates my point that these expressions have been around for a little while, even though they're very much being talked about at the moment. And I'm going to illustrate it using a manufacturing process called plasma deposition. Uh, Plasma deposition is quite a specialist process, and I don't particularly need you to understand how it works today, but it hopefully will illustrate the points that I want to make. So it's a specialist manufacturing process. The equipment looks like you can see on the screen here, and if you look through the glass window, this is what you'd see. The plasma is an ionized gas which glows, as you can see there. And if you get the conditions correct in the plasma, it can deposit a thin film on the surface of a component, and that's the purpose of the process. And if you look at it schematically, it looks like this. And the idea is that ions, charged ions from the plasma, deposit as neutral atoms on the surface of a component. It's a very complicated process with various different aspects, but we built an AI controller to control this whole process from pump down right to graceful shutdown at the end. So it is an agentic form of AI because it's detecting what's going on in the plasma equipment and it is acting upon it to control that equipment. It is making autonomous decisions, so it has agency. But it's also multi-agent because this process has various aspects, each of which uses a different AI agent for its specific task. So there are pumps to be controlled, and they need to be controlled in a logical, organized way. So that uses rule-based AI, sometimes called symbolic AI, which is based on logic. On the other hand, there is here the requirement to interpret the optical emission spectrum, and that is very much a pattern recognition task. And that was achieved using machine learning based on neural networks. There are also complicated electrical control requirements here, and we used a fuzzy logic controller specifically to maintain an electrical parameter called the DC bias. So it took various inputs and used fuzzy logic to maintain the DC bias at its desired point. So that was another specialist agent. And then the final example I want to give is this device called the Langmuir probe, which measures the energy in the plasma, the ion energy in the plasma. That device needs to be tuned or optimized, and for that purpose, we used a genetic algorithm, again with its own agent. So the overall process of controlling this equipment required multiple agents working collaboratively as a team, and I've highlighted the symbolic AI used in an agent for controlling the pumps, a fuzzy logic agent for controlling the electrical parameters, an optical emission spectrum analyzer agent using machine learning and neural networks, and finally the Langmuir probe optimization agent using genetic algorithms, all, as I say, working collaboratively as a team. So to sum up, what I've tried to illustrate today is that agentic AI and multi-agent AI are different terms. Multi-agent AI allows the right tool for each task working collaboratively. Agentic AI can detect and act upon its environment. So the two terms are different, but an AI system can be both agentic and multi-agent, as I've illustrated with this very specialized manufacturing example. Thank you very much for your attention and goodbye.